So, when we talked about instantaneous rate of change in class, the way to find it was that we were just estimating. So we took our average rate of change and we would get numbers that were closer and closer and closer to the number that we wanted it to be instantaneous to. So if we wanted it to be at 1, we would look at numbers like 1.5, 1.1, 1.01, 1.0001, and then we would have to estimate. Well, today I'm going to show you how to do it algebraically and get an exact answer so that we're not estimating. But first I just want to talk about the instantaneous rate of change and what it is. We already talked about average rate of change, and that was the slope of the secant line. And remember, the secant line connected 2 points on a curve. Well, instantaneous rate of change is the slope of the tangent line. And a tangent line is a line that touches a function one time, or in one place only. Okay, but you have to remember this is a line, and remember in geometry lines go on forever. So let's say we had the parabola that you graphed on the back of that packet last week. On this parabola here, if let's say I just had a point here, let's say it's some x value, and I'm just going to use a. And then my y value would be f of a, whatever I plug a into the function, that's what it would be. The tangent line is going to be this line right here. And that's not a great straight line, but it touches that function at one spot. Now, some of you might be thinking, and don't draw this in, because I'm going to erase it, but some of you might be thinking, why can't my tangent line be this one, or be this one? Those all touch the parabola at one point. And you're right, except for the fact that, remember, they are lines. So in geometry, these would have arrows. And so if this would keep going, it's going to touch it over here as well. Okay? If this would keep going, eventually it would touch it way down there. Okay? Because all of these have arrows. They do go on forever. So all of those would touch your parabola at 2 places. So they are actually secant lines. The red line that I drew first, that's the only line that is going to touch this parabola going through this point at one spot. So it's kind of just going to skim the side of it. Now again, if I wanted to find the slope of that line, I can't just use this point. Okay? If I would just use that point, I would end up getting 0 over 0. I would get the indeterminate. Okay? So instead, let's think about a point that's really close to this one. Okay? Now if I choose another point on that line, okay, and I think about, well, let's just make it a plus a little bit. And let's make that little bit be h. So whatever my value here is of a, I'm going to add just a little tiny bit to it. So I want h to be very small. Okay, so then my y value for that point is going to be f of a plus h. So if I'm going to find the slope of this, remember my slope formula is y2 minus y1. So here's y2, y1 minus over x2 minus x1. And notice in my denominator, these a's will subtract away. I'm left with this. And this is special. It gets a special name in calculus. It's called the difference quotient. And that's just taking the slope of 2 points that are very, very close to one another. So whatever a happens to be, we're just going to add a little tiny bit to it. We're going to add to h. Okay? And that's going to give us a good estimate of what the slope is. But we don't want estimates anymore. We want the exact slope. So we want h to be 0. That's what we want. But again, if I would plug h being 0 into here, I'm going to get the indeterminate. I'm going to get f of a minus f of a all over 0, which is 0 over 0. That's not good enough. Okay, so we want it to be 0, but we can't actually make it 0. So what are we going to do? We're going to find the limit. So instead, we're going to take the limit of the difference quotient. So we're going to take the limit of that. This right here is the foundation of calculus. Okay? And that's not a definition. It's not like if you look up what is the foundation of calculus. I'm not saying that that's like a definition or anything. I'm just saying this is what all of calculus is based on. That fact right there. Okay? So if we find the limit as h approaches 0, we'll be able to figure out what h is going to be when it is 0. Because remember, when we find the indeterminate, that means the limit does exist. We just have to find it a different way, and this is the way we're going to find it. This right here that I have circled, this is the instantaneous rate of change. This is how we find it. Now, you might also hear this be called slope of the tangent line. You might also hear this be called slope of the curve. So if it's asking you for the slope of the curve of a parabola at a certain point, it means this. It means the slope of the tangent line. Or this is going to be called the derivative of a function. The derivative of a function is the slope of its tangent line. Okay, and this is the first derivative test that we're taking. We're going to take, I think, 4 of them, maybe even 5. Derivatives are pretty much what all of calculus is, finding slope of tangent lines and how to do that all different ways. So we're going to be looking at pretty much every function you've ever seen before. Rational functions, square root functions, the trig functions. We're going to be finding derivatives of all of them. Okay, now it's not going to be all on this test or all today even, but eventually that's where we're going. We're going to find derivatives of everything. That's really what calculus is. So you can tell by what is in this circle right here is that these problems are going to be very algebra heavy. Okay, so I'm actually going to do 2 videos for these notes. This first video is just going to be for the front of the notes, and then I'm going to do a second one for the back, just because the problems do take a little bit of time because it is all algebra. Now this right here, this derivative, the limit of the difference quotient, you will not have to have that memorized. I will have it on the top of your test. So you just need to know how to use it. Same with your homework. When you see your homework paper tonight, I put this at the top of it. Okay, so this limit of the difference quotient you will not need to have memorized. So here's our first problem. Find the instantaneous rate of change for f of x equaling x squared at x equals 2. They always have to give you a place where they want the slope of, because, and don't draw this because I'm going to erase it, but the slope is going to be different all over this curve. It's changing. We talked about that already in class on Wednesday. It's always changing. It's not like a line that has a constant slope. It's a changing slope. So the slope over here is going to be different from the slope here. Is going to be different from the slope over here. All of those slopes are different. The curve is constantly changing. So they do have to tell you at what point they want the slope. They can't just say, hey, find the slope of this curve. Well, they have to let you know exactly where they want it. Okay, so we're going to find the limit as h approaches 0 of f of a plus h minus f of a over h. Now we are going to take this one little step at a time, and I'm going to kind of color code this as best as I can. Okay, so the first thing we're going to find is f of a plus h. Okay, now if I just wanted to find that with nothing else happening around it, we know how to find this. Okay, all we do is take whatever's in the parentheses and plug it in for x. So this right here is going to equal, and I'm going to keep the limit the same. And now f of a plus h is going to be a plus h squared. All I did was take a plus h and plug it into my function here for x. So you get a plus h squared. Okay, now I'm going to subtract f of a. Now, to find f of a, I am taking a and plugging it into my function. So a plugged in here just gives me a squared. Everything else stays the same. So I've kept everything in blue that didn't change. So now I need to simplify my numerator here. So I'm going to FOIL this. This is a plus h times a plus h. So after you FOIL, you're going to get a squared plus 2ah plus h squared. So all I did was FOIL this. And that's what I get. I'm not going to change anything else. Okay, so now I can simplify. I can see that my 2a squareds are going to subtract away. So I'm left with 2ah plus h squared all over h. Okay, and I still have this limit out front. And so now I have 2ah plus h squared all over h. So I just rewrote it. Now I can factor an h out of my numerator. So I have 2a plus h over h. So all I did was factor an h out, and now you can see your h's will cancel, which is what we want. Remember, at the beginning of all of this, we got the indeterminate. We're getting the indeterminate as a slope. That's why we have to go through this process. So you have to have something cancel, just like we did before when you got the indeterminate. That meant there was a hole in your graph, and you had to cancel to get rid of that hole so you could figure out the limit. It's the same process. So after these cancel, now I can plug 0 in for h. So I just get 2a plus 0, which is 2a. I'm almost done, but I'm not quite done. Remember, they want this at x equals 2. I talked about at the beginning of this problem how you have to have a function value to know where to find the slope at. So we're going to plug that 2 in here for a. So we have 2 times 2, and our slope is 4. So on the curve, x squared, when x equals 2, your slope is going to be 4. Okay, I'll let you take that all in for just a moment. Okay, that process is going to be the same process over and over again. As long as we are using the limit of our difference quotient, which is what we're going to use for all of these problems, this is what you're going to do. Okay, we're going to do this one, the next one together as well. I'm not going to set you loose just yet. So, again, I'm starting with, and I'm going to keep the colors the same to try to keep it all consistent. So, we're finding the limit as h approaches 0 of our difference quotient. And again, you will not have to have this memorized. This will be on the test for you. Okay, so now our function is x squared minus x at x equals 3. Okay, so again, the limit part, not going to change. Now, f of a plus h. So I'm just taking a plus h and plugging it in for x. So I had to plug it in 2 places because there's 2 x's. So I just took a plus h, plugged it in there. Now I'm going to subtract f of a. Now I'm going to put this in parentheses because I'm subtracting the entire function. So whatever that function looks like, that's what I have to subtract. On the last example, I only had 1 term, so I didn't have to worry about putting it in parentheses, but you could have if you wanted. So now I have to put it in parentheses because I have 2 terms there. And everything else stays the same. So now I have to FOIL again. So I'm going to have a plus h times a plus h. And then I'm also going to have to distribute that negative. So what I'm left with is, and I hope I don't run out of room here, I'm going to have a squared plus 2ah plus h squared minus a minus h. So I FOILed, and then I distributed the negative. And now I also have to distribute my negative here. So I'm going to have minus a squared minus, plus a, because I'm distributing. And then that's all over h. So now again, things are going to subtract away. My a squared subtract away, my a's subtract away. So I'm left with just 2ah plus h squared minus h all over h. I know that's a lot of h's. That's what we're left with. All my a's cancel away, or subtract away. So now I can factor out the h. I'm left with 2a plus h minus 1. The h's will cancel. Oops, forgot my plus sign. And now that my h's have canceled, now I can plug my limit back in. So 0 goes in for h. So I'm left with 2a minus 1. And now the last step, my x value. So I'm going to have 2 times 3 minus 1, which is 5. So my slope at that point is going to be 5. Okay? Now, I said I'm going to make 2 videos, and I am, but if you look at the next slide, I want you to try this one on your own. Okay, so when this video is over, try this one on your own. See if you can figure it out. There's just one little tiny difference there, but see if you can figure it out. Okay, and then you can start the next video, and the first thing I'll do on that video is how to go over this. Okay, so go ahead and try that one.